Welcome to True Projects. In this video, we are going to explain about a project titled Feature Extraction and Analysis of Natural Language Processing for Deep Learning English Language. The project explores the growing evidence of diverse data types and structures in various fields driven by the rapid progress of internet technology and scientific advancement. It emphasized that when observing a specific semantic concept or ontology, multiple observation methods can be employed to gather the data from different channels. These data sources originating from the different information channels provide the description of the same concept. Each type of information data is referred to as a different modality or observation perspective. Together, these diverse information modalities form multimodal data for addressing the same problem. The main goal of this project is to introduce a multimodal neural network approach for feature extraction and a hybrid neural network for English word segmentation processing. The objective is to address the challenges posed by the significant structural differences between various data modalities in the multimodal environment, which cannot be effectively tackled using the traditional machine learning methods. The proposed methods rely on deep learning techniques and aim to enhance the efficiency and accuracy of both feature extraction and word segmentation processing. The project also emphasized the importance of features extraction and selection in data representation, considering the specific challenges associated with multimodal feature learning tasks. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Wiki Sentence Dataset. In this module, the Wiki Sentence Dataset is uploaded for further processing. The dataset contains numeric sentences that will be used to train and evaluate the deep learning model for English word segmentation. The second module is Pre-processed Dataset. This module focuses on pre-processing the dataset before training the model. The dataset undergoes various pre-processing steps such as removing the punctuation, converting the text to lowercase, and handling the special characters or symbols. This pre-processing ensures that the dataset is clean and ready for further analysis. And the third module is Generate Word Segmentation BILSTM model. In this module, the word segmentation model based on bidirectional long short-term memory is generated. This neural network architecture is trained on the pre-processed dataset to learn the patterns and the relationship between the words in the English sentence. The model aims to accurately predict word segmentation. The fourth module is Generate Word Segmentation of BiGRU model. Similar to the module 3, this module involves generating the word segmentation model based on the bidirectional gated recurrent unit. The bidirectional gated recurrent unit neural network architecture is trained on the same pre-processed dataset to learn and predict the word segmentation. And the fifth module is Loss Comparison Graph. This module generates a loss comparison graph to evaluate the performance of BILSTM and BiGRU model. The graph visually represents the loss value of each model during the training and allows for the comparison of their performance. Lower loss value indicate better performance in the word segmentation. And the final module is Word Segmentation Prediction. In this module, the trained models are utilized to predict word segmentation for the new input data. The model takes input sentence and predict the corresponding word segmentation by assigning the unique ID to each word. The predicted word segmentation can then be compared against the ground truth to evaluate the accuracy and effectiveness of the model. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder. consisting of the sentences dataset and the test sentences test dataset. And this is the modal folder consists of HY files and PKLL files. Here, these files contain the algorithm interface information, and these files can be loaded into the project code during the runtime to utilize the trained model for various tasks, such as making the prediction on the new data or performing the specific operation. And features extraction is the main code Python file, and this is the run.bat file. Instead of executing the program in command line interface, we created the run Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Wiki Sentence Dataset button. By this, we are redirecting to the dataset folder consisting of sentences and test sentences. By this, we need to select the sentences and click on Open button. Here, we get a screen like this of dataset is loaded, and then click on Pre-process Dataset button. By this, the dataset is pre-processed and the total characters present in the dataset is of 3185 and the total OCAPs present in the dataset is of 39. And then click on Generate Word Segmentation BI-LSTM model. By this, the BI-LSTM model is generated on the pre-processed dataset with giving a loss of 1.10%. And then click on Generate Word Segmentation BI-GRU model button. By this BI-GRU model is generated by using the pre-processed dataset with giving a loss of 1.003%. And then click on Loss Comparison Graph button. Here, this is the loss comparison graph between the BI-LSTM and BI-GRU model. And this graph, x-axis represents the epochs or iteration and the y-axis represents the loss, and the blue line represents the LSTM and the orange line represents the GRU. And for both algorithm, we took the 100 epochs, and both algorithm loss is reduced for increasing the epoch, but GRU loss is little less compared to that of LSTM. So GRU is better than that of the LSTM for the word segmentation. And then close this graph. Click on Word Segmentation Prediction button. By this, it redirected to the dataset folder consisting of sentences and test sentences files. Here, we need to select the test sentences file and click on Open button. Here, the input sentence is of like this and the output word segmentation is of like this. In this way, we can segment the words by using the BI-LSTM and BI-GRU model. In conclusion, the project proposes a multimodal shared feature extraction algorithm based on the deep neural network and a hybrid network English word segmentation processing method. The proposed methods are based on the deep learning and the aim to improve the efficiency and accuracy of the feature extraction and the word segmentation processing. The experimental results show that the proposed multimodal fusion feature extraction model can effectively extract the low-dimensional fusion features from the original multiple high-dimensional data. The obtained fusion feature expression has a strong discriminative ability while possessing a lower feature dimension, thereby proving the validity of the proposed model in the terms of English word segmentation. The project has studied the LSTM and GRU in depth and proposed a hybrid network method that effectively solves the long-distance dependency of the test semantics, shortening the network training and predicted time. The proposed method has shown similar processing effect on the word segmentation as that of the BI-LSTM CRF model, but with an average predicted processing speed is of 1.94 times that of the BI-LSTM CRF, effectively improving the efficiency of the word segmentation processing.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.